Good morning, everyone. Am I audible to you? Are you able to hear me? Okay, thank you. Okay, let's start today's class. Today we'll start wherever we left in the last class, so we'll start from there. So I think we will discuss about some numerical about 3 hinge arc. Is there anyone have any doubt about this numerical? Did you try to do it by yourself? Okay, fine. There are some few same types of numerical that I will share with you. All of you please try to do that. So this is one other kind of numerical, almost similar with the previous one. So I think you can easily do this. Try to do it by yourself. I will not go through that. So today we'll discuss about how to draw ILD for intermediate and determinant beam. Okay. So for that there are some procedure how we need to do that. So there are some points we need to remember. So the first point is remove the constraint at the point of intersects. This means if influence line for a reaction is arc, simply start pretending the beam is no longer attached to the reaction and free to rotate about the other support. I think all of you understand this. It means that we have to assume that there is no support. So we need to remove that. Let make the beam free to rotate at any axis. This is our first step. So next is consider the remaining portion of the beam to have infinite rigidity, that is the beam is a straight line free to rotate above the support. Okay, so we consider a free hand is subjected to 1 kilonewton load, as we have already did in the previous derivation and numerical. Also we are assuming that unit load, assuming as unit load we will do the all the calculation and derivation. So our third point is rotate or displace the free hand in each positive direction, but only enough to create a deflection of 1 unit, because we are considering 1 kilonewton load. So we are everything we do in place of 1 unit. Okay. So here you see there is a determinant beam. Just L is the length given, and there is two distance A and B. So what is the ILD for RA and RB? I think all of you already know by considering 1 unit load. It's simply like this. So for bending moment also, this is just the simply drawing. Okay, just showing how it look like. So if you want to draw ILD for SF means shear force and how it look like, and ILD for BM bending moment at that point D how it look like. Okay, this is the standard values you need to remember. Just replace the length as per the length and all these things. You can easily find out the values. Okay, so just remember these things. This should be here. Okay, this 1 kilonewton load should be at the distance here. Okay, and this is point over D. Okay, so if you want to find out at that B point, this is your SFD and this is your bending moment. Okay. So in case of ILD for SF, the total deflection is 1, and in case of ILD for bending moment, total angle between the sides is 1 unit or 1 radian. This angle, okay, this angle, this should be 1 radian or 1 unit. So if we consider a direction, if we consider the length and all these things, how it look like. Just for example, if you see this is a total 5-meter length, we are dividing into 4 into 5 meter. So ILD at that point, just you need to use that formula AB by L. Just put the values. Similarly for the SF, you need to put the value A by L and B by L. So by simply calculating this, you can easily draw the SF and bending moment. Okay, this is standard formulas you need to remember. So similarly, if we go for indeterminate beam also, so in case of indeterminate beam, the shape of the ILD are not straight line; they are some have curve. Okay, so this is there is three support, one, two, three. Okay, as you see, this is the fixed and this other two is roller support. So for roller support, you may get also a curve. Okay, this curve. So how we will come to know? We will solve a numerical, then you can easily find out how it looks like. Okay, when we discuss about an example, then it is be easier for you to understand how it looks like. So here it is, there is a question. All of you please read it clearly. Draw the ILD for reaction or support A for a continuous beam. Calculate the coordinate of ILD at every 1 meter interval. So we need to find out the coordinate at every 1 meter interval. Okay. So this is a continuous beam. As you can see here, A, B, C, there is 3 points. This is a continuous beam. Length and all these things are given. So we need to find out the coordinate at every 1 meter interval. How we need to do this? Okay. So first we need to consider ordinate of ILD at A, means at this point, is equal to 1, because everything we are going to do by considering as unit load. Okay. So after that, ordinate of ILD at a distance x from C, this distance x from this point C, it's given by ILD at x. Okay. So how we need to calculate? Calculation of ILD coordinate at every 1 meter interval. So how much is the length? We need to find out the length. The total length is, as you can see here, 11 meter. So at every 1 meter interval, we need to find out the coordinate. So from ILD 1 to ILD 11, we need to find out. So for that, how we need to find out? There is a simple formula. Calculation of coordinate at any distance x. This is to remember. Okay. So for that, what is the formula? ILDS x is equal to, you see, displacement at x divided by displacement at the reaction point or point of intersect. And this, if you simplify it, you can also given as yx by ya. Okay. So what is our first step? We will go one by one. First, in our first step, what we need to do, we need to find out the support reaction. Okay, as you can see here, there is three reaction: RA, RB, and RC. Okay, so I think all of you know how we need to find out the reaction. For that, we need to use the equilibrium equation. So by using the equilibrium equation, you can easily find out what are the reaction or what are the support reaction at every point. Okay, so for that, first, we are using summation of MP is equal to 0. So we can easily find out by using this. All the load, all the distance, everything is given by considering 1 unit load. So RC you can easily find out from that by using the vertical equilibrium equation also. From that you can also find out the RP. Okay. So once you can say that there is 2, 3 support reaction, you can easily find out from here. Okay. Next, what is our second step? Our second step is calculation of moment equation. Okay, and remember here we have find out RC and RB. So you can also ask what is our value of RA. So for that we are considering RA as 1 kilonewton. Okay, RA we are considering 1 kilonewton because we need to consider as unit load. So we are considering one, and other two we can easily find out by using the equilibrium equation. Okay, so next is calculation of moment equation. For this, what we need to do, we need to consider a distance at x. X is distance from, at any distance from C. So taking moment for the line BC, this BC line, this line BC at a distance x from C. So I think all of you know how to take the moment. Mx is equal to 1.2 into x. So mx is also we can say as d square y by dx square is equal to mx by ey. This is the equation I think all of you know. So from here 1 by ei is constant. Mx value you can know 1.2x. Just put the value by derivation. By differentiation you can also simplify it. Just simplify these things. I think you know how you need to do this. I think all of you got it in the mathematics in third sem, fourth sem, everywhere. How to make the derivation. Just simply do these steps. Okay. So after finding this, you can finally you will get this equation. Y is equal to 1 by ei 0.2x cube plus c1x plus c2. Okay, so now we need to start from 0 to 11 meter. For that, using support condition where x equals 0 and y equals 0. So we need to put the value x and y in this equation number 1. So just put the value. By putting, you can easily find out what is the equation. After that, we need to put when x equal 5, y equal to 0, you will get another one equation. From that, you can find out the c1 value. So putting the values of c1 and c2, from here you will get c2 value. From here you will get the c2 value, and from here you will get c1 value. So just put this value in the equation. You will get another equation of y by putting the c1 and c2 value. Okay. This is very simple calculation. You can easily understand it. If just we need to go one by one. Okay. Just go through the derivation and all these things. Next point, what we need to do, taking moment for the line AB at a distance x from C. First, we did for this line BC. That's why here you see we are considering x up to 5 from 0 y0 to x0 from y0 to x5. So we are considering this line in the first case. That's why from 0 to 5 we are going from this side to this. Now we are considering this line AB. Okay, we are considering the distance x from C in the line AB. So again similarly you need to take the moment for this. I think all of you know how to take the moment. So just use that and you find the equation. After that again derivation part, you need to do this d square y by dx square. From here by simplification you can easily find out the equation of y. Okay, so again you put the value of c1 and c2. You can use the same c1 and c2 value whichever we already find out, because it is the constant. You can again if you find, you will get the same value. So directly put the c1 and c2 in this equation. You will get another one equation. Okay, this equation you can finally you will get this equation. Okay, after finding out these two equations, what we need to do, we need to find out the coordinate for BC and AB by using the x and y value. So what you need to do, you need to put the x value from 0 to 5. 0 1 2 3 4 and 5. Okay, just put the value in the equation. For BC you need to use the equation number 1. When you put the values you will get the y values like this. Okay, and for AB again you need to start from 6. because for this line, as you can see from this line AB, it is start from 6 to 11 meter. So you need to go from 6 to 11, 6, 7, 8, 9, 10, 11, and put the values of x in this equation. In the equation 2, you can easily get the coordinate. Okay, this is one part, it's over up to here. So now up to this, what we need to do, we need to find out the ILD at every 1 meter interval. So for that, there's a formula. I think already we discussed. ILD at x is equal to this equation. Just let me go through once again. This, we need to use this ILD at x equal to yx by ya, because ya is fixed. We know this is fixed 1 kilonewton. So just we need to replace from the right side to this up to this point. So just we need to replace this x in the above portion. X value will be changed from 0 to 11, and this y will be fixed. When you calculate, you can also get the same value as, just let me show you how you will come to know that our assume this is correct or not. Here you see, when you put the value, just start from 0. ILD at 0. See, y naught by ya. At y naught, y value is 0. Y is doesn't matter, but you can also put here 1. But anything, if 0, you will come, you will get 0. Okay. Similarly, when you consider x is equal 1, just put the value. Your y1 value is what? See, y1. This is your y1 value. This is your y1 value. This is your y1. And ya is nothing but your last value, this, because ya, when we will get ya, let you see, let me show you, don't be confused about this. We are starting from this point to this point. So at our numerical it is 11 meters. So from here 0 to 11 up to a, so a is our last point at 11. So at 11, what we got, let you check, let you see, at 11 we are getting 132 by ei. So our lower value will be same, just you need to replace the upper one. So for x equal 1, y1 is minus 4.8 by ei divided by 132 by ei. So after calculating, you can get the value. Okay, similarly at 1, after doing 1, 2, 3, 4, 5, everything you need to go one by one. So EI will be cancelled out. Just you can put the values, you can calculate, you will get the all ILD values. By doing this from 2, 3, 4, 5, 6, 7, 8, 9, 10, all these things, see finally what you will get at ILD 11. You see, you will get this one value 1, because at the final, what is our 11 by y a, but our ya is at that point is same as y11. So you will get exactly that one value which we have already assumed, means our calculation is correct. If you will not get 1 at the end point, means your calculation is somewhere it is wrong. Okay, so you see it will increase from 0 to going, see when the intersection point is there, you will get 0 also. See at y5 we are getting, when it is sense at y5, our value, if this is 0, see, when you put, after finding out this, you need to draw this diagram. Okay, see this, you need to draw this diagram. From here you need to start, this is your first point and this is your last y a value, this one 1, everything you will get. Okay, just try to do this, you can easily find out these things, very simple thing. Just try to do this, and after doing this, please try to solve this one. This is almost same. And in the next, there is another topic, so we'll not start that topic today. Is there anyone have any doubt? You can ask me. Okay.
Hello, sir.
Yes.
So I have a lot of doubts, sir.
Okay, Michael.
Sir, please can you go back to when we are finding the reaction?
Which one?
Reaction.
Reaction, na?
Sir.
Okay.
So why do we use equilibrium method?
Which one?
Because I thought if this is a determinant structure, why are we using indeterminate method to calculate?
No, no. This is
Sir.
indeterminate beam. No, this is a continuous beam. This three support is there.
Yeah, sir, but we're using determinant calculation to calculate indeterminate beam. Summation of
No, no.
force.
I have already said you know that condition. You have to assume that this beam as a free beam, as there is no support and all these things. That's why we are just drawing this arrow. See, just the arrow mark. We are remove the support. Whatever the support, we need to remove that. We need to assume there are some points. Now I have already said 3 points. Just go through these 3 points. These 3 points procedure for applying. Okay, these 3 points you just go through once. In these points it's already saying that we need to assume that beam as a free beam, okay, as there is no support and all these things we need to remove that. After that we need to use this equilibrium equation and we need to find out, and once you see we are already assuming this ra as 1 because we need to consider as one unit for unit load or unit 1 kilonewton, as you also you can say 1 kilonewton or 1 unit. So we have already assumed that this ra is 1, as you can see here it is written 1 kilonewton. Next we need to do the calculation for this rb and rc only. For that we are using this equilibrium equation. Okay, so you assume this ra as 1 unit, and also if you're assume unit load is correct or not, that you can also come to know from the calculation. If you are assuming 1 kilonewton is wrong, then you will not get this value as 1. This I am showing you this last value, this value will not get as 1. Uh, from calculation also you see you will get 1. Okay, just try to do once, okay, that then it will be clear to you. Others also please try to do. Without doing by yourself you will not able to understand. Just try to do, and please come up the doubt and all these things in the next class, because if you will not try you will not also know that are you able to understand or not. Michael, you please try to do once, and also if there is more doubt you can ask me. Okay, okay, all of you please give your attendance in the chat box also, okay, in the same time, and all, and once please go through the this, and I will also give some numericals, okay, from the books about the circular arc. There's some numerical I will give from the books. All of you please try to do that. Very simple numerical that may will get in the exam. If there is offline exam will be there, you may to solve these numericals. I will give some numerical. Don't worry about that. You can also download the PDF file from all these books.
Hello, sir.
Yes,
Sir, in case of exams, sir.
yes,
Sir, last time you gave us ILD for cantilever beam.
yes.
Sir, can you check that once? I think there's that last class we did IID for cantilever beam. But I
Okay.
think it's
What happened to there?
I think it's not so. That's not cantilever. Sir, can you check once? Sir?
Which one?
The
Which
last
one?
time IID for cantilever beam in case it come in exam.
Okay, okay. I will check that. Okay, you do one thing. You please send me the pics. Okay.
Okay, sir. I'll send you
Okay,
picture.
I will check that, because like this I'm also a little bit confused about what you are saying. Just send me the pics. I will cross check that. Okay.
Okay, sir. Okay, sir.
Okay. Just wait for some time. Let me mark your attendance. Integrated, everyone is present. Integrated, all
Present.
all four of you present.
Yes, sir.
Integrated, roll number one. Who is roll number one?
Michael.
Present, sir.
Michael. Yeah, Michael is present. Next, roll number two is there.
Yes, sir.
Then roll number three or four.
3, sir.
Three. Then five, no?
Yes, sir. 5 present.
Okay, fine, fine. Tashi is there. Tashi present. What about the others? I am not able to hear anyone's voice except Michael and sometime one or two. Are they all just joining the class or leave?
मनीष दस
Manish, हाँ तुम हो?
हाँ सर
ओ,
हूँ सर
कुछ बोलते नहीं हो सब
कैसे हो
कुछ।
सर कैसे हो आप
मैं तो ठीक हूँ, तुम लोग कैसे हो?